Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be discussing this lesson about circumcenter and incenter of a triangle. We will compare the uses of circumcenter and incenter of a triangle. Okay, to start with, let's take a look at these two figures. In this first figure, point O is the circumcenter of this triangle. In this figure, point I is the incenter of this triangle. Since point O is the circumcenter, then it means this is the center of this circle. Point I is the incenter, so it means this is the center of this in circle. Okay, going back to this figure, since point O is our circumcenter, then this is where this perpendicular bisector of these three sides of the triangle meet. Okay, what about incenter? Okay, incenter is where this angle bisectors meet. And since these are angle bisectors, then it means this angle bisector cuts this angle into two equal angles. Okay, in this figure, from this vertex to our circumcenter, vertex to circumcenter, these are actually equal in length because these are the radius of this circumcircle. So, considering this triangle A, B, O, this is an isosceles triangle. And as I mentioned a while ago, this is our perpendicular bisector. So here is 90 degrees. So it means here is also 90 degrees. So it means this is smaller triangle ADO and BDO are congruent triangles. Okay, we also have another isosceles triangle here. With this perpendicular bisector, then we have another congruent triangles. Okay, what about another isosceles triangle here with this perpendicular bisector? Then these two triangles are congruent. So, congruent triangles, congruent triangles, congruent triangles. And if we're going to check the relationship, so we have here right angle, okay, the hypotenuse, this would be the hypotenuse, and since two sides are equal, then that means RHS congruence. Okay, what about in this figure? So from the incenter to this point or to the midpoint of each side of the triangle, this is now our perpendicular bisector. So here's perpendicular bisector, perpendicular bisector. And these three lengths are equal in measure because these are the radius of our in circle. So if we are going to take a look at this triangle and this triangle, these two triangles are congruent. Okay, here, this triangle and this triangle are congruent. Triangle and this triangle are congruent. So we have here right angle. Okay, the hypotenuse, we will consider this one hypotenuse. And since this is our angle bisector, then this angle and this angle are equal. So we have RHA congruence. Okay, moving on, let's recall the concept about angle x plus angle y plus angle z equals 90 degrees. Okay, using the circumcenter and the incenter. So in this first figure, point O is our circumcenter. So it means from the vertex to our circumcenter, vertex to our circumcenter, these lengths are equal. So with this triangle ABO, it's an isosceles triangle. So if this is angle X, this is also angle X. So here, if this is angle Y, then this is also angle Y. Angle Z, this is also angle Z. Okay, what about in this figure? Okay, it's indicated that this is our incenter. So, angle bisector, angle bisector, angle bisector. So, if this is angle X, then this is also X. Angle Y, then this is also angle Y. Angle Z, angle Z. This is also angle Z. So, in here, angle X plus angle Y plus angle Z, that would be equal to 90 degrees. Okay, what about here? Get this angle, angle X, plus this angle Y, plus angle Z. That would be equal to 90 degrees. Okay, moving on. What about in these two figures? So in here, we are going to compare the relationship between this angle to this angle. In this figure, compare this angle to this angle. We actually had this one in our previous episode. So let's just discuss this one briefly. So angle BOC is 2 times the measure of angle A, since this is our circumcenter. So if angle BOC, let's say for example, is 80 degrees, then angle A would be half of 80 degrees, which is 40 degrees. Okay, in this figure or in this next figure, since this is our incenter, okay, so the measure of angle BIC is equal to 90 plus the measure of, or plus half the measure of angle A. So if angle A is 40 degrees, then to get BIC or angle BIC, that would be 90 plus half of 40, which is 20, then angle BIC is equal to 110 degrees. Okay, and for the last concept, we can actually find the area of a triangle even if the base and height are not exactly given. So, using the incenter of the triangle. So, with this one, we actually know that in finding the area of a triangle, we have here base times height divided by 2. What about if we don't know the base and the height of this triangle? So here, it's given that this is incenter. Okay, we know that these lines are actually equal in length because these are the radius of our in circle. So, half times radius times A plus B plus C. What does it mean by this one again? So, from this vertex to incenter, vertex to incenter, vertex to incenter, these are actually equal in length. So, if we're going to check triangle ABI, this is a right triangle. So, half times base times height. So, here, this radius is actually the height of this right triangle. And this segment AB, or this measure represented by C here, is the base of this right triangle. So, instead of height, if the given is radius, then we can still find the area of this triangle. So, we have here 1/2 times the radius times A plus B plus C, or this is now the perimeter of the triangle. So with this formula, even if we don't know the base and height, then we can find the area of the triangle. Just remember that the height is the radius, or this radius of this circle or in circle. And A plus B plus C is the perimeter of this triangle. Okay, this time, let's answer this simple question. Triangle ABC is an isosceles triangle. So this is ABC, or triangle ABC. AB, or segment AB, is equal to AC. So this side is equal to this side. Point O and I are the circumcenter and incenter of triangle ABC respectively. So this is point I, so this is our incenter. Point O this point, so this is our circumcenter. So if angle BOC is 140 degrees, we will find the following: angle BIC, ABI, and IBO. So we have here given that this angle BOC is 140 degrees. So we will be using this measure to find the measure, or we will be using this clue or measure to find the measure of these three angles. Since this is our circumcenter, then angle BOC is times 2 the measure of this angle A. So 140 divided by 2, then that means this angle is 70 degrees. Okay, the first angle that we have to find is angle BIC. So we have here BIC, or this angle. Since this is our in-center, then to find the measure of angle BIC, it's gonna be 90 plus half the measure of angle A, which is 70 divided by 2, that would be 35. So 90 plus 35, then angle BIC is 125 degrees. So this is 125 degrees, or this angle. Okay, now, what about angle ABI? So ABI, or this angle. Okay, since this is our in-center, so that means this is an angle bisector, angle bisector. So if this is 70 degrees, then this angle is 55 degrees. This is 55 degrees. 55 plus 55 plus 70 is 180 degrees. So this is angle bisector. So half of 55 is 27.5. So 27.5 degrees. So here, 27.5 degrees also. So ABI, or angle ABI, is 27.5 degrees. Okay, for the last angle, it's angle IBO. So angle IBO is this small angle. Okay, so since this is our circumcenter, and this is 140 degrees, okay, then it means this angle and this angle are equal. So 180 minus 140, then that's gonna be 40 degrees. So divide by 2, then it means this is 20 degrees. This is also 20 degrees. So finally, IBO is gonna be, okay, so this is angle bisector, 27.5 degrees. So meaning this is also 27.5 degrees. So 27.5 degrees minus 20 degrees to get the measure of angle IBO. And that would be 7.5 degrees. So angle IBO is 7.5 degrees.